This lesson is about Pythagorean Theorem. You guys have been dealing with Pythagorean Theorem for probably a few years now and probably know that a squared plus b squared equals c squared. So we just want to kind of go over this again just to refresh your memory on how to work those. Okay. So in your notes that you have, just follow along. You can record. You can also, rewind, pause, things like that, so you can jot things down as I'm going over it. Because I'm going to try to go over it pretty fast. Because the software that I'm using only allows so many minutes before I have to do another one. So I'm going to try to do it all in that time. Okay. So the first thing is I did kind of want to point out is that it talked about the Pythagorean theorem being a Greek mathematician named Pythagoras who came up with this. However, they said there's been records of it being used in North Africa for hundreds of years before this guy even lived. Okay, so this has been going on. So this theorem has been going on for years. So, but let's just move on to example 1. Show that that 3, 4, 5 is a Pythagorean triple. Pythagorean triple is using the Pythagorean theorem when everything is a whole number. No decimals, no radicals, no anything. It's a whole number. So that's what we want to show in this. Now, when it comes to the A, B, and C, C is always the one that's the hypotenuse and is always directly across from the right angle. So you'll also note that the hypotenuse is always the longest side. Okay, so the hypotenuse is always the longest side. So let's look at that in our first example. Show that 3, 4, and 5 are Pythagorean triple. So it doesn't matter which one of these are A and B. We just know that the longest side is always C. So we have 3 squared plus 4 squared is equal to 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. So yes, this is a Pythagorean triple. Now I want us to show that this second example is also a Pythagorean triple. So we have our A and B. So we can have 5 squared plus 12 squared is equal to C squared. 5 squared is 25. 12 squared is 144 and is equal to C squared. 25 plus 144 is 169 is equal to C squared. And to get rid of this squared, we have to do the opposite of squaring something. So the opposite of squaring something is square rooting. So we take the square root of both sides. C squared just becomes a regular C. And then 169, the square root of 169 is 13. That is a whole number. Therefore, now we have a Pythagorean triple. Everything being a whole number. So that's us showing that we have a Pythagorean triple in this problem. So in this one, we have an example A here. We'll do the same things what we have been doing. Of course, the C squared is always the longest one, which is the 41. So we set it up 9 squared plus 40 squared is equal to the longest side squared, which is the 41 squared. 9 squared becomes 81. 40 squared is 1600 is equal to 41 squared, which is 1681. So by the time you add 81 and 1600, add them together, you end up with 1681, which is also equal to 1681. They check out. So yes, that will be a Pythagorean triple. I would like for you guys to pause this and try B to see if it is or isn't. Okay, I want pause the video, work it out yourself, then push play, watch me do it, and see if you get the same things and right things. So in B we have 50 is going to be our C. That's the longest one. So if we set it up like we're supposed to, 10 squared plus 49 squared is equal to 50 squared. Let's see if this is a Pythagorean triple by them actually adding up to equal each other. 10 squared is 100. 49 squared is 2,401 is equal to 50 squared, which is 2,500. So when we add the left side, we end up with 2,501 is equal to 2,500. These are not equal to each other, so therefore this is a no. This is not going to be a Pythagorean triple. So in this for an example 4, we want to try to figure out what the other side length is. So in number 1, we have the hypotenuse, or the C, and then we have the two legs. Okay, one of them could be A, one of them could be B. It doesn't matter which one you label. Just make sure the hypotenuse is C. Everything else, then the other two, really doesn't matter which order you put it in. So we have x squared plus 9 squared is equal to C squared, which is 11 squared. Okay, still following the formula. Sorry. Even at home, this is a mess up. So we have x squared, 9 squared is 81, 11 squared is 121. So when you subtract 81 from both sides, you end up with 40. So you have x squared equals 40. To get x by itself, we do the opposite, which is take the square root. So x would equal, now if we're looking for approximation by rounding, you can take the square root of 40 from your calculator and you'd end up with 6.3. However, if we want to know the exact, this is what we're talking about when we talked about this during midpoint, and we have to simplify the radical. So we take the square. If we take 40, the biggest square that goes into it is 4 and 10. So the square root of 4 we know that's 2. The radical 10 we can't do anything with it, so it'll be 2 radical 10. So depending on what you're being asked in whatever assignment or whatever problem you do, your answer could be 6.3 or it could be this. Just depends on what you're being asked. So that's always pay attention and follow directions. So since these were not whole numbers, then they are not going to be Pythagorean triples. However, I do want to point out that this is approximate. This is approximate, and the one with the radical is exact. Okay, just remember, it just depends on what you're being asked to do. Again, I want you to pause the video, do this on your own. After you get done with it, press play again and see if you get the right answer. If we set this up, then we end up with 10 squared plus x squared is equal to 20 squared. Remember, 20 is the C, is the hypotenuse, directly across. So we end up with 100 plus x squared is equal to 400. So by the time we subtract 100 from both sides, we end up with x squared is equal to 300. So if you actually took the square root of 300 in your calculator, you'd end up with x is approximately 5.5, or if you did the exact of this, you have the square root of 300, and you can take the square root of 103. Square root of 100 is 10. Radical 3 we can't do, so that's just going to be the square root of 3. So these could be your two answers. So again, it asks you, is it a Pythagorean triple? No, it is not, because you don't get whole numbers as your answer. Let's skip over number 3. Be sure to put an X on it, so for notebook check reasons, you won't get counted off if you don't do it. But let's take a look at number 4. Number 4 is a little bit different because it has a radical in it already. Again, we're going to set this up using our formula. Our C is going to be the one across from the right angle, which is the hypotenuse, which this time is going to be X. So this one's going to be 4 squared plus 4 radical 3 squared is equal to X squared. 4 squared is 16. Now 4 radical 3 squared is like saying 4 radical 3 times 4 radical 3. And if you remember from Algebra 1, you do the outside times the outside, inside times the inside when it comes to your radicals. So if you do the outside times the outside, it's 4 times 4, which is 16. Inside is radical 3 times radical 3, which is radical 9. Radical 9 is the square root of 9, which we know is 3. We already have a 16 on the outside, so then you multiply those two numbers. And when you multiply 16 times 3, you end up with 48. So 48 is going to be there equals x squared. So then you have 48 plus 16. You end up with 64 is equal to x squared. Take the square root of both sides. X is going, the x squared cancels out to be an x. The square root of 64 is 8, so x is going to be 8. The next question is asking about a baseball diamond. And this is my poor attempt of a baseball diamond, but when you have a baseball diamond, it's basically a square, and each base is 90 feet away from each other. Okay, it's asking you what happens what's the closest distance to the nearest tenth of a foot, so we're going to be rounding, from first to third. Okay, so what you'll notice is that is basically going to be your hypotenuse. This is going to be your 90-degree angle, so that's going to be your hypotenuse. So to set it up, this is also going to be our C. So we're going to have 90 squared plus 90 squared is equal to C squared. 90 squared plus 90 squared is going to be 8100 on both of them. So when you have 8100 plus 8100, you end up with 16,200 is equal to C squared. Take the square root of both sides. When you take the square root of both sides, then your answer is going to be approximately, and I'm putting it over here because I'm running out of room, 127.3 feet. So from first to third is roughly going to be about 127.3 feet. The last one talks about a jogger who runs 8 miles north, so they go up, and then they go 5 miles to the west. So that'll be this way. What's the best way they can go to come back home? So that would be the shortest distance doing this. So we have 8 north, 5 west. So now this is the part we want to know, so we could still do our a squared plus b squared equals c squared. So 5 squared plus 8 squared is equal to this last part, because that is going to be our hypotenuse, which is x squared. So by the time you work this out, 5 squared plus 8 squared is going to be 25 plus 64, which when you add them together is 89. When you take the square root of 89, you get approximately 9.4.